Okay, I'm back, and now we want to talk about what empty space is. So empty space is the same thing as virtual space. And what this means is that surrounding us and permeating us is a infinite amount of energy. And for short periods of time, this energy can be converted into matter and antimatter. So we know that according to Einstein, E equals mc squared. So if you've got enough energy, you can manufacture matter and antimatter. And so matter and antimatter pops into our universe for very, very short periods of time. Then it goes back together again, turns into energy, and then it returns back into empty space or virtual space. So this is happening all the time. Even in the room you're sitting in, there are particles of matter and antimatter that are appearing in front of your eyes. It's just that it's all happening so quickly that your brain can't register it. This is important because this is a possible explanation for where did the universe come from. So that a matter universe and antimatter universe appears out of this infinite amount of energy, but before it had a chance to come back together again and disappear, the universe expanded. So that's a possible theory. Okay, I'd also like for you to have an understanding for the different kinds of hotels that are predicted by quantum mechanics. So the atomic hotel had energy levels where electrons would live. So the electrons that are in orbit around the nucleus of an atom live in the atomic hotel, and then as those electrons jump up and down, they can absorb light and they can emit light in the visible and ultraviolet parts of the spectrum. Okay, then we also talked about the nuclear hotel, which is in the nucleus of every atom. And so this is going to be where protons and neutrons are going to live. And so they also can jump up and down in the nuclear hotel. Well, this one is going to be the nucleon hotel. A proton and a neutron are called nucleons. So let's say that this represents a proton. So it's going to be 3 quarks that are going to always live in the hotel. And then if they get struck by energy, those quarks can jump up and down energy levels. Well, you can also have other kinds of particles that are popping in and out of existence from this virtual energy, from virtual space. And so that's all explained on this video here. But I did want you to recognize that inside protons and neutrons is yet another kind of hotel where the quarks live. Okay, and then don't worry about this, talking about where does the mass of a proton come from. So that's not going to be on the exam. All right, now let's talk about dark matter. So you need to know that regular matter, which is going to be composed of quarks and leptons, it makes up only 4% of the universe. Dark matter is going to make up 23% of the universe. So there's almost 6 times more dark matter in the universe than there is quarks, leptons, protons, neutrons, atoms, regular matter. So what is dark matter? Well, we don't really know, but we do know that dark matter has mass. And we also know that it does not interact with light. You cannot see dark matter. That's why it's called dark. And you can't see it, but it does have mass, so it does cause gravity. So how do we know that dark matter exists? So one has to do with the rotational rate of galaxies. According to Kepler's laws, galaxies should be rotating at a certain speed depending on how much mass that they contain. However, when we look at it, these galaxies, using light, we notice that they're rotating at the wrong speed. And in order to make them rotate at the speed at which we see them rotating, we need to pretend that that galaxy has more mass than what we can see. And that missing mass is the dark matter in those galaxies. Another thing that dark matter can do is it can bend light. Anything that has mass causes gravity. Gravity can even bend the trajectory of a light beam. And so if we look at a very far away object and there's dark matter in between us, then it will cause the image of that object to split into two images. And so we can actually see this. So what is dark matter? Well, we don't know. So the only thing that you need to worry about is the neutrinos. So that a possible candidate for dark matter is a neutrino. Don't worry about the baryons, don't worry about the axions, and also don't worry about the superpartners. Okay, now let's talk about the dark energy. We know even less about dark energy. We think that it makes up 73% of the universe, even more than what dark matter does. Now, we don't know what it is, but we do know what it does. So that dark energy has properties of being anti-gravity. Regular gravity pulls everything in, but this dark energy pushes stuff out, and it's causing the expansion of space and time. Now, you don't notice it in the room around you because dark energy is very, very weak whenever distances are very small. The larger the distances get, the greater dark energy gets. So that by the time you get to the distances out to clusters of galaxies, then you start to notice the effects of dark energy, and it's causing the universe to expand. So what is dark energy? We don't know. So one possibility is that it's energy that's leaking into our universe from virtual space, because we said virtual space had an infinite amount of energy. So maybe it's leaking into our universe, and then that's causing the expansion somehow. Okay, then the other possibility is that our law of gravity is incorrect. So we think that the force of gravity is minus a fundamental constant, the gravitational constant, and then it's mass number 1 and mass number 2, and then divided by r squared. So that's the current theory for what gravity is, and it pulls everything in. But maybe there's another term. So maybe there should be a plus opposite to the minus, and it should be some other kind of force of gravity, but it's repulsive. And it depends on r, the same way this one does, but this one gets stronger as r increases. So we don't really know which explanation is correct about dark energy. So for purposes of the exam, I'm just going to ask you, what does dark energy do? And I'm not going to ask you what dark energy is. Okay, let's take a break, and when we come back, we will talk about what are the fundamental forces that control the universe.